Have you ever wondered how our journey into space really began? Let me take you back to January 31st, 1958. Picture this. The United States launches its very first satellite, Explorer 1, into low Earth orbit. It wasn't just a metal tube spinning above our heads. It was a bold leap into the unknown, just a few months after the Soviet Union shocked the world with Sputnik. Explorer 1 was a true pioneer. It was a slender, cylindrical spacecraft, just over 2 meters long and only about 6 inches in diameter. Weighing in at a mere 14 kilograms, it looked more like a science project than a space probe. But don't let its size fool you. Inside, it was packed with scientific instruments, including a Geiger counter, designed to answer one big question: what's out there in space? Now here's where things get really cool. Explorer 1 made one of the most important discoveries in space science: the Van Allen radiation belts. These are zones of charged particles trapped by Earth's magnetic field, and Explorer 1 was the first to show they even existed. But how did it get up there, and what kept it moving? Let's talk physics. First, the orbit. Explorer 1 traveled in an elliptical path around Earth, ranging from just 358 kilometers at its closest to 2,550 kilometers at its farthest. That means its average orbital radius was about 8.9 million meters from Earth's center. To find out how long it took to complete one orbit, I used the orbital period formula T equals 2 times pi times the square root of r cubed over g times m. Plug in the numbers: orbital radius, gravitational constant, and mass of Earth, and you get about 8,383 seconds. Divide by 3,600, and that's roughly 2.33 hours per orbit. Imagine circling the Earth in less time than a movie. Next up, orbital speed. Using the square root of g times m over er, Explorer 1 zipped around at about 6,688 meters per second. That's over 24,000 kilometers per hour, fast enough to cross the United States in less than 10 minutes. In space, gravity is still at work. The gravitational field strength at Explorer 1's altitude was about 5 newtons per kilogram, almost half of what we feel on the surface. The gravitational force pulling the satellite toward Earth? Around 669 newtons, thanks to the mass of both Explorer 1 and our planet, calculated with Newton's law of gravitation. Explorer 1 didn't have fancy solar panels, just batteries. It braved wild temperature swings and the harsh environment of space. After just 4 months, its signals went silent, but it stayed in orbit until 1970, burning up in the atmosphere after more than 58,000 trips around Earth. So next time you look up at the sky, remember Explorer 1. The little satellite that proved big things are possible, and paved the way for every mission since. Who knows? Maybe your journey to the stars starts with a question, just like Explorer 1.